Hello, ladies and gentlemen. Let's look at Chapter 4. Now, I kind of consider Chapter 4 a variety of different things going on here. We're going to look at more relationship between two variables. Chapter 4.1 is about nonlinear data. And then we go into two-way tables and we deal with the categorical data. Okay? So, Chapter 4 is a little bit weird. Also, we're not going to do all of Chapter 4.1. We're going to just scan it. Okay, we're just going to do a brief summary of it. We could spend 3 days on Chapter 4.1. But 2 years ago when I was at Augsburg getting retrained and learning more stuff about AP Stats, the instructor said if you're going to sacrifice anything, Chapter 4.1 or this section, the nonlinear part, you could sacrifice on that. And because of the distance learning, we're going to need to do that to save a little time, because I don't have 3 days to spend on 4.1. I really only have a half a day, and then because we're going to do part of 4.2 also for this lesson. All right, but that'll be in the other video. So what are we looking at here? We're looking at nonlinear data. So obviously a linear regression will not fit it. So let's look at, and I still want you to read the examples in this book, and they're going to get into some transformations. Now, if you really want to know about it, dive into it. And if you have questions, please visit me during my office hours, and we'll go through some of those nonlinear transformations, because it is a really good thing to know. Now, so example 4.1 is dealing with modeling mammal brain weight versus body weight. Interesting, huh? So if we look, we can see this first graph on page 260. Now, you can see that we have, well, this is a hippo, this is dolphin, and so on. Body weight, brain weight. Okay, and we can see the elephant way up there. Isn't that interesting? Okay, but, you know, we've got some outliers there. If we take a closer look at just this part of the data, you'll notice that, let's do a zoom in, that it's really not linear. Okay, it's kind of curved like this. And we'll discuss what's going on there, okay? So we're going to look at, well, what's a possibility? Why is it curving in that way? And you'll remember some of these things from advanced algebra. So what they did to straighten it out, okay, so this is what they did to straighten it out. They took the log of the body weight. So they took the explanatory variable and they took the log of all of those numbers, and it actually straightens it out, okay? So you can find, whoops, wrong button. You can find this on page 261. So again, read through that, ladies and gentlemen. Okay, and then underneath you'll see there's first steps in transformation. Okay, well, again, I'm not going to have you actually physically transform any data. We're just going to look at it and be able to say something about it. All right, here we go. So there's a fish. All right. So here's another example, okay? This is example 4.2 in your book. So 4.2, we've got the fish tournament transforming data with powers. Okay, so in this situation, they're taking and they're doing a power to one of the variables. So let's just go ahead and take a look at it. So here is the length of the fish, and here's the weight. And you can see that it is growing like that. All right, well, they straightened out the data, and this is how they straightened it out. They cubed each of the lengths. There's lots of different ways you can transform data, and that straightened it out. Now, what we would normally do with that is we would actually convert that equation back. We would, since we did that transformation, we would need to figure out the equation that would fit. Okay, but we're not going to do that. Okay, we don't have the time for that. Here is the residual plot for that data after it was straightened out. Okay, so you can see right here, and again, you can find this on the next page, page 264 in your book. Okay, please look at that. All right, after you transformed it, then we could figure out the equation, and look at how nice that line would go through it. And you can find that equation on page 265 in your book. All right, this is dealing with the fish. Now, there are different, the dots are going to make different patterns, okay? So on page, let's see, on page 268, there is this display of what is happening to the data. Like this orange line right here, okay, you notice that x to the 4th power, it's exponential. It's going up very quickly. All right, so you can look at that display. I've got another one here I want to show you. So if you have a line, or the dots, if the dots are curving up in this fashion, ladies and gentlemen, to straighten it out, we could do the log of y, okay? Here's another weird one, okay? Log of x, if it's looking like that. Quadratic, there is no transformation. Reciprocal, that's 1 divided by x. That's what that would look like. Whoops, wrong thing there. Hold on. All right, square root. Okay, you might remember some of these patterns from advanced algebra. And then we've also got the power where we do the log of x and the log of y. Again, I'm not going to ask you to do any transformations with any of this. All right. So here's another one. Okay, it's looking like that. Here they straightened it out a little bit by taking the square root of x. Here they took the log of x and it straightened it out a little bit more. And then, wow, it totally reversed directions. They took 1 and divided by the square root of x. Okay, so read through those examples for chapter 4.1. Again, linear versus exponential growth. Linear growth increases by a fixed amount in each equal time period. Exponential growth increases by a fixed percent of the previous total in each equal time period. All right, here's another one. These are all examples in your book. This would be the properties of logarithms if we were going to go through that. So I'm not going to ask any test questions, obviously. So what I want you to be able to do, ladies and gentlemen, is I want you to be able to describe what you are seeing. Okay? I want you to be able to describe, like this one. It's nonlinear. The correlation is going to be positive. But remember, correlation is only for linear data. You cannot rely on your R, your correlation at all if it's not linear. Okay? So here what they did to straighten out this data was they took the natural log of the distance and it straightened out a lot. And then here's the residual plot. Not very good though, is it? There's a pattern to it. Okay? So look through, ladies and gentlemen, look through those. Read through them. Read the description of what the dots are showing you. But you don't need to worry about the conversions. All right? So that's all we're going to do for chapter 4.1. Be able to describe what we're seeing. Shape. Okay, curved. What type of curve is it? Is it exponential? Okay, etc. And then that's all we're really going to do with it, is describe it. We're not going to go through those transformations. I hope that made some sense. Okay, again, read the examples, read through each example, so you get the general idea of what we're wanting, or what we were supposed to do for chapter 4.1. But again, I'm sacrificing a couple of days here so that we can get through all of the other stuff, which is more heavily tested on the AP test. If they test this on the AP test, it might be one question, and if that's the only one you miss, well, you're still going to get a 5. So we're not going to worry too much about chapter 4.1 other than being able to describe what you're seeing. Okay, sorry, I babbled on for quite a while there. All right, ladies and gentlemen, see you in the next one. Chapter 4.2, we're going to do, I'm going to do 2 lessons on it because part of it is going to be with this lesson, but it's going to be go to Chapter 4.2, and then we'll do a day 2 on Chapter 4.2 because there's a lot of stuff there that we need to talk about categorical variable and tables and graphing and so on. All right, ladies and gentlemen, we'll see you in the next video.